So now that we know how to conduct a hypothesis test for matched pairs data, now we want to be able to do the other inferential statistics piece, which is create a confidence interval. Before I get into that, just let me remind you really quickly that the hypothesis test that we were doing here was extremely similar to the one that we were doing in Chapter 10 when it was only one population. Now it's two populations, but they're matched together, so they're paired up. So the formulas involved a lot of D's because it was for differences, but other than that, it was a very similar process to what we've already learned. Same thing is going to happen here with the confidence interval. So we have a lower bound and an upper bound. The critical value T alpha over 2 is determined using n minus 1 degrees of freedom, and D bar and SD are the mean and standard deviation for the differenced data, just like they were before for the hypothesis test. And again, the interval is exact when the population is normally distributed and only approximate if it's non-normal, and we can deal with that later. All right, again, I have calculator instructions for those who are interested in it, and I have the lovely confidence interval formula right here. So we're going to construct a 95% confidence interval for the mean difference of that same touch therapy data that we saw before. Okay, so it's D bar plus or minus T alpha over 2 times SD over the square root of n. Well, D bar, remember we learned, was negative 1.923 plus or minus, let me copy and paste this. This number right here was 1.605. We already found that. The square root of n is the square root of 13. We already found that. And that leads us to T alpha over 2. All right, so since it's a 95% confidence interval, that means that alpha, yeah, I better put it up here. So it's 95% CI. That means that alpha is 5%. Put a little arrow here. So alpha is 0.05 because they're complements of each other. And that means, I can use the implies arrow, I suppose. So that means that alpha over 2 is 0.025. Oopsie, 25. There we go. All right, so that's my column, and my degrees of freedom, let me just remind you of that, is 12, right? Because it's 13 take away 1. So I can either use the calculator with these two numbers or use my table. Let me grab my table real quick. All right, so the table, I would go to the 0.025 column, and I would go to 12, and it's 2.179 right there. Or I could use the calculator, do second distribution, that's above your variables button. You want number 4, and you say 0.025 or 0.975, either one will work, and enter. And there it is. Now remember, TID3s cannot do this. Only TID4s can do this. So 2.179. All right, so let me pull up the thing. So this is 2.179. Now I have no intention of doing this by hand because that would just be silly. I'm going to make make the calculator find this for me. So I'm going to go to Stat, Tests, and we want an interval. So you're going to skip over all the test ones. This isn't a Z interval, it's a T interval, right? So we're going to use T interval, number 8. And let's see here. We want statistics this time, right? Oh no, I guess not. We still have the data in there. It's in L3, right? So we can leave it data because it's from that Reiki touch therapy data that we already used back a few pages, right? Okay, so let me pull that up. All right, so then we want a 95% confidence interval. Go down to calculate, enter. And there it is. Negative 2.893 to negative 0.953. All right, let me fill that out. Negative 2.893, comma, negative 0.953. And there's our final result. Okay, so we showed the formula here. We showed the substitution here, all parts of it. And then we showed the result. Done with that. All right, what was the point estimate for the difference in pain levels? Well, that would be, hold on, let me put this in. That would be D bar. D bar is the center of your interval, right? In our case, it was negative 1.293. There we go. So it's the center, remember, the point estimate is the, well, it's not really the center all the time. It's the center for these ones because these are symmetric. So it's the sample statistic used to build the interval, which in this case was d bar. Okay. Now what's the margin of error? You know what, let me pause. I'm going to draw you a picture. Hold on one second. Okay, here's the number line. Over here is the left-hand edge at negative 2.893. Over here is the right-hand edge of your interval, which is negative 0.953. In the middle is that sample mean, d bar, which was negative 1.923. Now the error is the distance from that middle bar to those edge bars. It's half the width of the interval, right? So let me type that up. All right, so error is half the width of the interval. That's half the distance between negative 0.953 minus a negative 2.893. So we would just find what that is and divide it in 2. Or if you like, you could take the difference between the high end minus the middle. All right, let me grab the calculator. So I'm going to take negative 0.953, take away a negative, I can do parentheses, negative 2.893, close parentheses. I don't know really why I put the extra parentheses in there, but so the whole interval across is 1.94. So I'm going to divide that by 2, times it by half, and I get 0.97. So that's my margin of error. So this is equal to a half times, what was that? I forget. 1.94, that's it. 1.94, which is equal to 0.97. That's my error and your error. That's the interval's error. All right, done with that. All right, so now what does this mean? This means we are 95% confident that the Reiki touch therapy lowers pain level in patients between 0.953 points and 2.893 points. Now, why don't I put negatives? Well, because I use the word lower, right? So lowers implies the negative, right? So, or if you want to think of it this way, it didn't really matter which way was positive or negative. All that mattered was that they were both negative, right? Because we set up the hypotheses so that it was after minus before. If you'd done before minus after, then they would have ended up being positive numbers, right? But you're 95% certain that it's lowering it somewhere between almost a full point and almost 3 full points. All right, does that confidence interval suggest that there's a significant difference in the pain levels between the two groups? To which we say yes, for sure, right? We're almost sure that we're lowering it somewhere between 1 to 3 points. And remember, you can see it back here in the box plot that we drew of this data. If I could get to the box plot. There it is. You can see the after is significantly lower than the before, right? So we're lowering the numbers from before to after by 1 to 3 points, and that's what the interval is showing us. That somewhere between 0.953 and 2.893 points are we going down. So if that's the case, then yes, we're significantly lowering it, because if they weren't being significantly lowered, what would happen? Let me go back to the hypotheses for a second. If it wasn't significantly lowered, the null hypothesis would stand. The null hypothesis is that there is no difference, that the before and after are basically the same, which would mean that your confidence interval would contain 0. 0 is your null hypothesis. So you got to look at your interval and think, wait a second, did my interval contain 0? Because if it does, that's the null hypothesis. Well, no, it totally doesn't contain 0, right? So that's why we think that this is significantly lowering it. The graph is getting significantly shifted down from one box plot to another, meaning the difference between the two groups is not 0. The difference between the two groups is significant, right? Because the confidence interval of the differences does not contain 0, this implies that there is a significant difference in the pain levels between the two groups. Okay. And again, all because 0 is in there. If you want to make a note to yourself, not a significant difference. Significant, I can spell. Difference would be something like negative 2.893 to positive 0.953. Right? Then 0 is contained in that interval, which means you don't know whether the touch therapy is doing any good or not. Right? That would what it would take to be a not significant difference. Okay? Let me bold that. Okay? All right, but since our interval didn't contain 0, our interval went from a negative number to another negative number. So, or it could have, if you would have gone the other way, if you would have done before minus after, it would have been positive 0.953 to positive 2.893. Either way, that would imply a significant difference because 0 is not contained in that interval. That means that you're rejecting the null hypothesis. The null hypothesis is that the difference is 0. By having intervals that don't contain 0, you're implying that there is a significant difference. All right. I'm actually going to skip the next question, and I'm going to come back to it in the last video. I'm going to skip ahead a few pages and do this lovely confidence interval output right here. So the U.S. Census Bureau publishes information on the ages of married couples. Suppose we want to determine whether in the U.S. the mean age for married men differs from the mean age of their wives. A random sample of 10 married couples is taken and their ages are recorded. And then I give you the Minitab output and some StatCrunch output. So a whole bunch of stuff. So the researchers published a normal probability plot, that's right here, between husbands and wives. Why is that important? Well, because we have a small sample size, right? We've only got 10 husbands and wives, so 10 pairing. So because the sample size is so small and the data we need to show, and the data were not known to be normally distributed, we need the normal probability plot to show us the data are normal before we can proceed. There we go. All right, what was the point estimate for the difference between men and women? That would be right there, 3.6. That's your D bar. There, I had to pause you and go fill that out. So D bar is 3.6. That's your sample difference. The margin of error is the difference between the edges and that center. D bar is the center of these intervals, and this is the edge over here. So you can find that by taking 1/2 the difference of these two, like we did on that other one. Or you could just take the, so here, error equals upper limit minus D bar. So that would be, I don't remember what number that was, 7.156. So 7.156 minus 3.6, which would be 3.56. I suppose I didn't really give enough room there to do that. Or you could take 1/2 of upper minus lower. So you could take the upper limit minus the lower limit and cut that in half. That would work as well. Either way, that's your error. Okay. All right, so again, upper minus center. You could do center minus lower. That's another way too. So there's 3 different ways. Upper minus the center minus the lower, or take 1/2 of the upper minus the lower, because the margin of error is the distance from that center out to those edges. Now, does this interval suggest that there's a significant difference between the ages of husbands and wives? Yes, because 0 is not contained in that interval, right? There appears to be a significant difference. There we go, that's all typed up, right? Since 0 is not contained in the interval, there appears to be a significant difference. Remember, if there's no difference, then mu d will be equal to 0. That would be your null hypothesis. But since our interval right up here does not contain 0, that would mean that there is a significant difference. It's not by much because that lower limit's pretty small, but it's still higher than 0, both of them. So that would mean that there is a difference.